This is going to be tough because everybody's slowing down to look at it. I'm Dan Edmunds, and this is, well, you all know what this is, right? It's a Cybertruck. This happens to be the 3-motor Cyber Beast, which has a 6-figure price tag and pretty incredible acceleration. But whether you're attracted to the origami stainless steel styling or not, there are some pretty unique features to this truck. So I am going to pull the really unusual looking wheels and tires off there and have a look at the suspension, and then later I'm going to put it on my RTI ramp to see how much the suspension flexes. You won't want to miss this. Before we get started, there's a couple things you need to know about the steering, which is part of the suspension. This wheel is pretty much a yoke because that's lock to lock. That is not even a full turn. Pretty amazing. So these are LT 35-inch load range D Goodyear off-road tires, and they've got these are rubber. So I guess so they don't hurt the tires. I don't know, but there's no hole here to put air in it. And why is that? Well, we have to pull them off to see that, and I have to pull them off to take off the lug nuts anyway. So here's the air valve. Now the air valve is in a fixed position with the wheel. Fine, they all are. That's why hubcaps can have a hole in them. But these hubcaps have to line up with the tires. So they line up with these little notches, but the tire can be mounted anywhere on the rim. There's no orientation that's really possible to hold true. So the actual wheel cover spins slightly with much difficulty to line up with this. But what it means is there's no right place for a hole. So if you want to check your air pressure, you got to have the wheel covers off. And maybe just don't put them back on because, you know, there's not a lot of aero benefit to them. So here's the front suspension of the Cybertruck, and it's pretty massive stuff, as you would expect for a vehicle that weighs almost 7,000 pounds. This is double wishbone suspension, dual control arm suspension, take your pick. It's a high mount upper arm, which means this arm and ball joint are above the top of the tire, which are just below this bolt. Aluminum knuckle. Stamped steel upper arm, and one of the reasons why you use a high mount upper arm is so that the loads are smaller in the upper ball joint and the upper arm mounting points because of the leverage. Below, the lower control arm is aluminum, and I see a fixed stabilizer bar, some pretty cool looking air springs over the shocks, and kind of massive calipers and interesting looking rotors. Let's get in closer. Here's the air spring, and there's a little air hose that comes into it. This is the upper control arm and its ball joint. This position sensor feeds back to the air suspension, for the height adjustment feature. It's not what the shock uses to do its adaptive damping, though. That's built into the hub. And of course, big aluminum knuckle. Of course, the rear leg is much lower than the forward leg, which is anti-dive geometry. that limits the amount that the nose of the truck will go down under braking. The Tesla is a unibody with a stressed stainless steel skin. They call it an exoskeleton, but really there's a skeleton beneath the exoskeleton, and we're seeing some of it here. This is the front casting, goes all the way up, picks up the upper control arm. You can see these little cells. That's so it progressively collapses in a crash, but then below there's a subframe that carries the lower control arm, the steering, the stabilizer bar, and the electric motor. So yeah, you're seeing a little bit of the bones beneath the stainless right here. This is the lower control arm down here, and you can see that the stabilizer end link attaches to it right here, and the shock, the coil over or bag over, since it's airbags instead of a coil, bolts right there. So I've turned the wheel so we can see a little bit better. Here is a connection that goes into the hub that's going to be the ABS sensor. There is a G sensor that's part of the adaptive damping system, and I don't know if it's co-located with this or not. Here's where the steering linkage attaches, and there's this little extension here. This isn't really very heavy, so I can't imagine it's a mass damper. It might be a mud scraper to clear debris off the inside of the wheel as it goes by. Lower control arm down here, it's got this plastic cover, so it's aerodynamically smooth on the bottom where the air goes over it. The shock absorber bolts here, stabilizer bar here. Here's the link and the bar itself. And of course we've got the steering rack, which goes in there. And what's neat about this is steer by wire, like a jumbo jet. There isn't a connection to the steering wheel. And that's how the steering can be less than one turn lock to lock, and you can turn it easily while it's parked through that entire range of motion. It's a 48 volt system, the whole truck. All the accessories are 48 volt, and that's why there's enough power to be able to move these big 35-inch tires underneath this 6,900 pound truck while it's parked without a whole lot of effort. Pretty amazing. So here is the bushing for the big stabilizer bar, and back here that's one of two drive motors for the steering rack. There's two of them, so there's redundancy because it's steer-by-wire. It's redundant with two motors and also triple redundant with 3 feedback sensors, and they're all connected to different circuits so that if one goes down, there's still 2 more that can talk to the computer and make sure everything goes good. Here's something we see on a lot of vehicles. There's a little notch here and a little thing that sticks out here. So at full lock, this will make contact with this, and that will signal the end of travel for the steering. These shock absorbers here are Bilstein monotubes, and they have independent control of rebound and compression damping. And there's 2 ways you can go about adjustable damping. You can either set your base valve to the soft position and engineer valves to add damping as you go through more and more sporty settings. And doing that requires that you use some electricity. So a lot of electric cars go that route where they have a soft base valve and then they add their damping in the performance mode by spending a little electricity. But this truck goes the other way. The base valving in there is the stiff setting, and these valves bypass to make the softer setting. So they give up a little bit of electric consumption because if you want to run in a soft mode, you're going to be bypassing and energizing these valves all the time. But they wanted to do that because this being a truck that can tow 11,000 pounds and has a significant payload, they wanted to make sure that if there was any kind of a failure, that it would default to the stiffest setting, not the softest one. And that's for safety. And the other reason why they can afford to do it is a little bit more wonky. The Cybertruck has a GVWR over 9,000 pounds, which means it is actually exempt from EPA testing and labeling. So they don't have to worry about every little electric expenditure for range and consumption because they're not being graded on that. So they can take a little bit different approach than somebody who's trying to maximize their range in the softest default setting. They don't have to do that here because they don't have an official range. Not really. They give you a number, but they don't necessarily have to follow the procedure to the letter. This lower control arm is very A-shaped. The forward bushing here is pretty much in line with the outer ball joint. So the lateral cornering loads will go through this one, which is why it's oriented like this, so that the bushing can absorb this way. The rear leg goes far to the rear, and so that's where longitudinal impact. So if you hit a pothole and it pushes the wheel back, that will push into here, and this bushing is arranged this way so that it can compress inward when the wheel goes back. These front calipers are pretty massive. I mean, that is a big hunk of metal. It's got a fixed bridge because they don't want this caliper jacking apart when you put on the brakes, because this thing weighs 7,000 pounds and can tow 11,000 pounds and can go 0 to 60 in 2.0 seconds. It can do 11-second quarter mile. Yes, I measured those and that's what I got. It's no joke, and you need lots of brakes, and this caliper, I can't tell if it's 4 or 6 piston. I'm seeing these little vague round issues here, which features in the casting, which make me think it's 4 piston, but really big pistons. But if I took it off and saw 6, I probably wouldn't be terribly surprised. But again, it's a massive caliper. Changing the pads means you got to pull these 2 bolts to pull the whole rotor off, because the pads have to come in from the other side. This is not like your typical open window design that lets you just pull them right out. But of course, it's an electric vehicle, and electric vehicles do a lot of regenerative braking. So these pads and rotors may last a really long time, probably as long as you own or lease this thing. It's not like a regular vehicle where you go through a lot of brakes, because most of your braking is going to be magnetic through the regenerative braking system. So this is here, and the size of these is here because of the speed potential and the towing potential and the payload potential of this probably faster than it should be truck. Well, that's it for this look at the Cybertruck's front suspension. I'm going to wrestle this big old tire back on here, button things up, and move to the back. See you there. Well, here at the rear of the Cybertruck, we've got some of the same ingredients, but like burritos and tacos, they're mixed together differently. This is a dual control arm rear suspension, double wishbones. We have an air spring over a Bilstein adaptive damper. We have a fixed stabilizer bar, but it's not the same stuff. I mean, if you just wrote that down, it would all look the same, but obviously it doesn't look the same. So here is the upper control arm, and it really does deserve the secondary name wishbone, because it certainly looks like a wishbone. Here's a height sensor again for the air spring to get its feedback. You can see it bolted to a similar aluminum subframe that carries, here's another piece of it, that connects the battery tray to the front suspension and the side panels that hold the doors, all together underneath this same stainless steel skin. Of course, this air spring, supplied by Firestone, like many of them are. Back here is the rear steering actuator. You may have seen that the rear wheels turned in opposite phase with the fronts here. Parking on the freeway, they tend to go the same phase as the fronts to stabilize things. And of course, that's why we have a very long linkage, steering linkage that comes from that. All of these control arms and this steering rod are very long because this has a lot of rear travel, 12 3/4 of an inch of rear travel, a little bit more than the front. But It's a pretty significant amount. As you can see, we're seeing this subframe everywhere, and the spring bolts to it right here, just behind this little plastic guard. The lower control arm is very broad, and like the front one, the shock absorber and its air spring bolt here to the arm itself, and the rear stabilizer bar also bolts to this tab on the arm itself. Like the front, the main valve that's fixed, that never changes, is the stiffest setting. And to get comfort and other softer settings, these valves bypass fluid away from it, so it's not as effective. And so in that regard, if you're in a comfort mode, you're always going to have these energized a little bit. But if there's a power outage or something takes out one of these wires, this will default to the stiffest setting, which is definitely what you want in a truck that can haul as much as this one can. Like many rear stabilizer bars, this one's not very big. You can see it snaking around back behind this little plastic trim piece, and that's the bushing on the back of the subframe here. Here's a lower control arm here in the rear and its aero cover. This little flip here to help bring the air around the inside of the tire. Here's the inner pivot, and you can see it's really long, and the outer pivot's right here. This is the ball joint, the nuts here, so the axis is right here. And of course, you want dual control arm, double wishbone with one ball joint top and bottom, because this has rear steer, so you have to have a pivot axis in the back. And if you had, links or something, you wouldn't have that. As for the rest of the truck, the whole underside is really flat. I mean, compared to something like an F-150 or a Ram or a Chevy ICE truck, the underside of those is just a jumble of frame rails and tanks and void spaces. The air's just chaotic underneath there. This is very well controlled. So when you think about the aerodynamics of this truck, you have to remember that whatever the top looks like, the bottom looks like this. So it's very, very smooth underneath. One of the things I noticed under here are these bolt holes. There's a whole line of them along the side all the way to the back. And I have to think that those are going to be for accessory rock rails that we don't see yet. This, by the way, is the place I'm putting my jack. It's a reinforced jack point. It even says it right here. But those look like good places for rock rails to bolt on. The rear brake is a single piston sliding caliper. You can see the piston right in there, just barely. The two pins on which it slides. Electric parking brake actuator, and a ventilated rotor that's got a lot of thermal mass. It's pretty thick. You don't need as big a brakes in the back, even for something like this, because, all the weight transfers to the front, and that's where most of the braking action happens, and this is just kind of keeping it balanced. There's something else about these tires that are unusual. Have you picked up on it? Well, we know they're Goodyears, but what's the model number? It just says Goodyear. And there's a tire size over there. And DOT number, and that's kind of it. So what are they? Well, you got to turn them over to see that. Now you can see that they're Goodyear Wrangler Territory RT, and that says electric drive ready, so low rolling resistance for EVs. These are load range D right there, and the size is LT 285 65R20 123/120H. They're M+S rated, not 3 Mountain Pete Snowflake. They're not that rating, and that size works out to 35 inches. So yeah, these are 35s. What does one of these bad boys weigh? Well, let's find out. $88.2 pounds. I should probably point something out about the rear suspension. It's got air suspension and the whole truck raises and lowers. But the squat mode where the rear goes down to ease loading that you saw 4 years ago on stage, it doesn't do that. Maybe it will in the future, but it doesn't now. I mean, over-the-air updates we'll see, but it doesn't seem to be in the plan. Now to make it a truck, I can push this button here. Tonneau opens, push this button here. Tailgate goes down. This is not powered, it's just falling under its own weight and it's damped. But what you're seeing here, there's a little cargo compartment here, but there's no spare tire here. This truck doesn't come with a spare. In order to get the bottom as aerodynamically smooth as it is, they couldn't afford a spare under there. If you want one, you can put one in here, but that's pretty much up to you. They'll sell you one, but it doesn't come that way. Well, that's about it for this look at the rear suspension of the Tesla Cybertruck. Of course, this is a cyber beast, but I don't think it'll look any different if it wasn't, except I wouldn't see the motor so close on this side. Anyhow, a lot of this looks pretty big and heavy duty. It sure drives nice. I have spent some time driving it. I haven't towed anything with it, but it rides real nice despite those big, almost 90-pound tires that have 50 PSI of air in them. These Bilstein dampers are tuned really nicely for daily driving. They soak up cracks really well. It rides much smoother than it looks, I should say. Next step is to put this on my ramp in the backyard and see how well the suspension flexes. It's got 12¼ inches of travel up front, 12¾ here at the back. It does have a longish wheelbase of 143.1 inches, so that'll factor in. But yeah, we'll see. I mean, it is independent suspension front and rear. There's no solid axle here, so you know how people think about that. It is a long travel rear suspension, at least. The front didn't look extraordinarily long, but it does have 12¼ inches of travel. So yeah, I really don't know what to expect. There's only one way to find out. So I'm going to put this wheel on and get to it. Well, I need to play around with heights. I'm going to try the lowest off-road mode and see if I can do a high on-road mode, which is a little lower than that. You know, I want to be able to clear the air dam, but I also don't want the springs to be so full of air that they're rigid and inflexible. So let's see. Well, we've got plenty of clearance here. This is high mode, which you can see is much higher than entry mode. This is, I think, it goes entry, and then the on-road modes are low, medium, high, low being freeway cruise. And then the off-road modes are higher than that, high, very high, and extract. Interestingly, though, these little wings in front of the tires are actually lower than the center. So normally, trucks are cut up in front of the tires to give more clearance, but here they're trying to keep the air going around the tire, and so these things hang down a little more, which is a little bit weird. Well, here goes nothing. This is high mode, which is the lowest off-road mode. Got two motors in the back that are negotiating with each other, and yeah, I'm going to turn this off and give this a think. Well, the answer is not nearly as complicated as I was trying to make it. It's not an issue of the traction control like I thought it was. It's more related to the weight distribution of this truck. The Cyber Beast, because it has two rear motors, weighs more in the rear than it does up front. So that means when I go up the ramp, the tire that lifts off isn't going to be this one. It's going to be the right front over there. And you can see the daylight. So I've obviously gone too far because that wheel's off the ground. So it's going to be a little tougher because I can't quite feel what's going on or see it really, but I'll get there. So I'm going to have to back up a little bit until that tire just barely touches. Well, I moved it the smallest amount I thought I could get away with. I can kind of move it, but can I put this underneath it? Not quite, but I'm going to call that right there. All right, time to measure with this. At first I thought I would take this off because it just snaps on. But I figured with all these little geometric edges here, it might actually help me line up the middle better. Now it's not going to work because this isn't a multiple of 6. It's a multiple of 7. So this isn't across from here. So it's really screwing me up. There. It's still 7 here, but 6 on the lug nuts. So that'll help. And I can see the middle of the center bolt real nice. I'm going to call it right there. So this point right here is 18 1/16 of an inch off the top, which is 18.0625. And now I'm going to divide that by the sine of 20. And I get 52.81. So 52.81 goes here. Sorry, that's a 2. And then the wheelbase is 143.1, and I got that from the spec panel in the owner's manual that's right there in the truck. So I take 52.81 and divide it by 143.1. And then I multiply this by 1,000. And I get 369 as the flex index, the RTI score of the Cybertruck in the lowest off-road mode, which is called high. Now I'm going to go down a level and measure it again. Why not go up? I mean, go more off-road? Because the higher you make an air spring, you're doing it by pumping air into it, and that makes it stiffer, and that means it flexes less in a situation like this. So actually, the most flex is at the softest spring state, which is the lowest height. Now, I wouldn't do it in entry height because you can't even drive at entry height, but certainly you can drive in a height that's lower than this. Now, this is the lowest off-road mode, so you could argue that anybody who just sticks it in off-road mode is going to get this amount of flex, which is okay, but not great. It's certainly not body on frame great. It's certainly not at least one solid axle great. I mean, this is independent suspension all around. There's lots of travel, no doubt about that, but it's also got some pretty decent sized stabilizer bars because, well, it's pretty heavy. Anyway, I'm going to roll it back down. I'm going to put it one mode lower than this and do it again. little better. It's weird because I like overlapping the throttle and brake when I'm driving an internal combustion engine vehicle up this ramp, and you can't do that with this truck. It's either gonna confuse the motors and turn them off, or you just have to go and be very careful on the throttle so you don't go into the garage. Ooh, that did something. I also felt a little teeter. This is getting a little close. I don't think I can go any lower than this, so I think the medium setting is the lowest setting I can do this ramp, because otherwise that's going to get buried in the edge. The reason why this is all a little fidgety right now is because, well, I can't see that corner, because normally it's this one and I can have a much better sense of what's going on just looking over my shoulder. The other reason is, this has a mechanical locking front differential, but the software hasn't been pushed out yet. So it's coming soon, maybe just a week or two. By the time you get yours, if you're going to get one of these, it'll work just like Toyota TRD Off-Road or Jeep Wrangler diff lock. It's not electronic. I mean, it's electronic, but it's mechanical within the differential. The rear of the Cyber Beast, because it has two motors, well, they have to simulate it. And that's probably what the holdup is. They haven't got that totally ironed out, and until they do, they're gonna launch them both at the same time. And if you get the dual motor one, you'll have mechanical lockers, front and rear. So yeah, I think all that's coming into play here. But also, I can't see or really feel what's going on that right front corner when I'm doing this. So here we are. We did make some progress. Let's see how much. All right, I'm going to call that it. And this is the benefit you get running in medium mode instead of high mode. I know that's counterintuitive, but again, the springs have less air in them. That's why the truck settles lower, but it also allows them to flex more. Just based on this rough scale here, it's just a little bit over 7 inches more climb by doing that. But what is it exactly? Well, for that I need my tape measure. 20 9/16. So 20 9/16 is 20.5625. And we'll take 20.5625 and divide it by the sign of 20 and get 60.1, which is, pretty decent improvement from 52.8 inches of climb. Of course, the wheelbase is still 143.1. So we divide by that, multiply by 1,000 to get it into the RTI format, and we're at, I can't believe this, but 420. You think they did that on purpose? I don't know. So here is where the Cybertruck stacks up against the other electric pickup trucks that I've measured. I haven't got a Hummer on here yet. That's the main one I'm missing. Anyway, all three of these have independent suspension, front and rear. You can see the Rivian R1T, like the Cybertruck, does better in its default mode than it does in a lifted off-road mode, 510 versus 488. But of course, the Cybertruck, and I can't believe these are the numbers, 420 and 369 for its on-road and off-road modes. Of course, the Lightning down here is 332, so pretty far behind both of these. And I think we know what's going on here. The Rivian has hydraulically disconnectable stabilizer bars that are pretty trick. Cybertruck has fixed ones. The Lightning also has fixed ones, but it's an adaptation of a regular F-150 and not something that's a clean sheet design. So I don't think they care much about off-roading with that. It's more of a standard pickup truck that can tow, that's electric. But here's where you can put this all into some perspective. And that's when I move the camera up. I see all of these favorites that are traditional pickup trucks. And the only one that's, these two here, well, actually a couple of these would drop behind the Rivian. The Rivian really, well, the Rivian gets pretty high. Here's its 488 here. And the 510 goes all the way up here. So the Rivian, when you think about all the other trucks that are out there, then you go down here, and then you find the Cybertruck and the Lightning. So yeah, independent suspension, height adjustable, tons of clearance, not a lot of flex. Primarily because it has fixed stabilizer bars to go with all that stuff. And it doesn't have disconnectable ones like the Rivian. And of course, all the rest of these, usually have at least one solid axle. And that helps them.